Now let us get into the details related to MapReduce APIs to manipulate collections. We can process data in collections using different approaches, conventional loops, MapReduce, etc. So this is conventional loops approach where we have an aggregator which is initialized as a set here to get distinct order dates. And then once we start iterating each and every element in orders, we extracted the date and we started adding to the set. And as set only contains unique elements, finally we got all the unique order dates returned for the orders that are passed as argument to this function. We can also validate by saying get distinct order dates and orders like this. Here I'll be invoking length to get the number of elements from this. You can see that it is 364, even though the orders is actually 68,883. The reason is we only get unique order dates as part of this dataset. Now if I have to get unique order statuses than order dates, then I have to define a new function like this, and then again I have to say order statuses equal to set for order in orders order statuses dot add order dot split of comma of 3, which is nothing but order status, and then return order statuses. And you can actually invoke get distinct order statuses on orders to validate whether we got all the unique statuses or not. And you can see that we got all the unique order statuses. Again, we got a set which contain the unique order statuses, which are around 9 elements, even though our input data contains 68,883 records. If you compare these two, except for this, rest of the logic is same. You have initialized to an empty set, and then you are iterating through the elements in the collection, and then you are extracting the information you want. Only this part is changed. But to add to a set, you are using the same API called as the add, and you are returning the aggregator which is initialized to empty at the beginning and appended as part of the loop as part of this return statement. So except for this, everything else is same. By leveraging the concept of passing functions as arguments, we can automate this in such a way that we don't need to come up with iteration logic every time we want this similar kind of functionality. So here I can say def get distinct info, or just get distinct. You can pass any collection. The second argument can be a function. So I'm just naming it as f because we want it to be used for different purposes. We are just giving some highly generic names here. As we are trying to get distinct, we can say dist equal to set, and then I can iterate through the elements in the collection for E in C for element in collection, and then I can say dist, which stands for distinct, dot add. Here, instead of having the logic to get order status or order date, we'll be invoking a function, and that function takes element as argument. And then finally, we will return dist, which is nothing but distinct elements from the given collection. Rather than returning as set, I want to return as list, and hence I'm saying return list of dist, and hit enter. Now we got the function definition. However, we don't have the function definition for this lower order function. We have to pass it while invoking this get distinct. So here I can say get distinct. The collection is nothing but orders. And in place of function, either we can pass a named function or a lambda function. In this case, I have chosen the lambda function. And as part of the lambda function, we will be passing one order at a time, because this function also takes one element at a time from the collection. And hence I can say lambda order, which is nothing but one order at a time. And then to get distinct order statuses, I just have to say order dot split of comma of 3, and it will give us the distinct order statuses like this. If you want to get the dates, you can say of 1. I just want to get 10 of them. As it is list, I can actually provide the subscript notation like this and say colon 10 to get first 10 records. If I want to get order customer IDs, I can say order dot split of 2 like this. However, order customer ID is of type integer. It is better to typecast it to original type like this, and you can see the results. You got the first 10 order customer IDs. So like this, you can actually reuse the code at a much higher degree than compared to using conventional loops for each and every scenario. In this case, we only use the data from orders. If we want to get distinct information from any other collection, we can use this function. This one function can be served hundreds of use cases where we want to pass a collection and extract distinct of certain information in that collection. That being said, In this case, it's a special scenario where I have developed some logic. Out of the box also, there are APIs which are nothing but MapReduce APIs. So the core Python itself provide APIs such as map, filter, etc. There are tools like functools which provide APIs such as reduce. There are tools like iter-tools which provide robust MapReduce APIs. And then we have much broader pandas where we have a data structure called as data frame, which is extension to a list, and it has much better and readable APIs to process the data by just focusing on the business logic without worrying too much about the technical aspects of creating variables, iterating through the collections, and then appending to the collection, and then returning the collection at the end. Okay, so if you are adapted to MapReduce approach or pandas approach, your productivity will significantly go up compared to using conventional loops approach. That being said, as we understand some aspects of MapReduce APIs, now let's get into the details. MapReduce APIs such as filter, map, etc. take care of initializing the aggregator, looping through the elements, as well as returning the aggregator for us. So if you actually look at the source code of APIs such as filter, map, etc., it has the loop logic. However, the business logic with respect to filter is typically to filter the data. Map is to transform a record into another record. Using this, we just need to focus on business logic. We don't need to worry too much about the initializing the aggregator, looping through elements, as well as returning the aggregator for us. We can look at the help on filter. You can see that filter takes two arguments. One is function, second one is collection. Similarly, you can look at help on map. It also takes two arguments. It takes function as first argument and collections as second argument. You can actually pass as many collections as you want as part of map. Map is typically used to process each record and return a different record within a collection, whereas filter is used to create a sub collection. Whatever satisfies the condition which is passed to filter as part of the first argument will be added to that new sub collection. Others will be discarded. We will see examples very soon. Now, once we get the data, if we have to sort the collection, then we need to convert the collection to list, or we can use sorted function also. List provides an operation called as sort. We can use sort to actually sort the data. Once we extract the information, if we have to eliminate duplicates, then we need to convert the collection to set. Now let us see how we can create a collection from a file and then apply MapReduce APIs to compute revenue for a given order item ID. Not order item ID, it is item order ID. First, let us review the data. So here I am opening another tab and I am going to research data retail DB. It contains a directory called as order items. We have already seen orders. If you look at order items, file called as part-5 you can see that each line is kind of a record, and the first element is order ID and the second element is item order ID for which this order item belongs to. The first element is the order item ID, not order ID. Second element is the order item order ID, which is foreign key to orders. So order ID in orders is unique, and here this order item order ID is representing the order ID in orders. So for the given order with ID 2, we have three elements here, and for these three elements, the order item IDs are 2, 3, and 4. And then we have product ID, and then quantity, and then subtotal, and then product price. This fifth element, which is nothing but a subtotal, is nothing but product of order item quantity and order item product price. You can see here 5 times 50 is 250, and you can see 250 here. All these 6 attributes, order item ID, order ID, product ID, quantity, subtotal, and product price, are separated by comma. So comma is the delimiter in this case. Now using this data set, we want to compute revenue for a given order item order ID. So we should develop a function or logic where we take order item order ID as argument. Then we have to filter based on this order ID. Once we filter based on this order ID, we have to extract this order item subtotal, and then we have to add these to actually get the revenue for given order ID. So let's focus on the function here. So first and foremost, we have to read the data into a collection from the file. So order items equal to open 5 zeros and then read and then split lines. Now you can see the len of order items to get the number of elements in this collection. We have 172,198 of them. Now I want to first filter for order ID 2. So I'm creating a function which says get order revenue. We'll be passing order items to this First, we'll be creating a variable called as orders filtered. We'll be using an API called as filter, and the output will be converted to list, and hence I'm using list here. Actually, we don't need to convert into list. We can directly use filter. Filter takes two arguments. The first argument is the function, and the second argument is the collection, which is nothing but odd items here. So as part of this function, we'll be processing one odd item at a time. So I'm saying OI here. I want to compare whether the odd ID is 2 or not. So the second element after splitting by comma contains the odd ID. So here I can say int of y dot split of comma of 1. We have to compare with 2. So it will only have those three elements which contain odd ID as 2. From that we have to extract this part, which is nothing but the fifth element after splitting. So here I can say orders or order item subtotals equal to orders filtered. So map has to be applied on orders filtered. So we have to start with map. It takes a lambda function, and then we have to say y dot float, because the odd item subtotal is of type float. We'll come back to the logic in a moment. In this case, we have to pass only the filtered orders. So we can actually pass orders filtered as second argument, and then we have to say y dot split of 4 to get the odd item subtotal for each and every odd item after filtering. Now it will contain those three subtotals, which are nothing but 199.99, 250, and 129.99. If we pass already as 2, we just have to add those three elements. There is a function called as sum, so I can say return sum of order item subtotals and hit enter. Now we can say get order revenue. Actually, the function should take two arguments. Anyway, we have hard coded with the 2. That's fine. So we should be able to validate, and then we will improvise on it. So get order revenue, order items, and hit enter, and we got the revenue for given order ID. However, here we have hard coded the order ID, which is not good, and hence we will improvise in such a way that the function takes two arguments, order items and then order ID, and then we can actually say orders filtered equal to whatever logic it is. But whenever we want to compare the second element after splitting, we want to use the argument that is passed, which is nothing but order ID, and then odd item subtotals, and then return. Now we can invoke this function with 2. We will get the revenue for order ID 2. If we give 4, we'll get revenue for order ID 4. Like this, we can use map and filter to come up with revenue for given order ID. So whenever we have to come up with logic for this kind of problem statements, first we need to filter the data, and then we have to apply the transformation rules, and then we have to aggregate. So when it comes to aggregate, you can use predefined functions like sum, the way we have seen here, or we can use reduce, where a bit complex aggregations can be performed on top of simple aggregations like sum. So in this case, if you want to use reduce rather than sum, let us look at the help on reduce. Reduce is not part of the core APIs. That's why you will not see the help for this. However, there is a package called functools. So you can import functools as probably func, and then you can say help of func.reduce, and you can hit enter. So reduce takes two arguments. One is the function, and second one is the collection. So sequence is another synonym for the collection. This function takes two arguments like this, and those two arguments can be used to aggregate the data. So in this case, we are trying to add. So if you are trying to pass collection like this to reduce, so as part of the first iteration, this x and y will be 1, 2, and then we are trying to say x plus y, which means it will return 3. Then x will be reset to 3 and y will be 3. In the second iteration, x will be 3 and y will be 3. Those two will be added, and we'll get 6, and x will be reset to 6. And in the third iteration, x will be 6 and y will be 4. Those two will be added, and in the fourth iteration, x will be 10 and y will be 5. And finally, we will get 15 as the final output. Okay, so we can use reduce approach if you want to perform aggregation or any complex operation which is part of our aggregation requirement. That being said, if you want to use reduce in place of sum, we can refactor the code by saying orders filtered and order item subtotals will not change. However, when it comes to this part, it will change. First, we need to import functools as func, and then I can say order revenue equal to func dot reduce, and then lambda x comma y, x plus y, and then we have to pass order item subtotals and then we can say return order revenue and hit enter. Now we can actually say get order revenue, and then the first argument is nothing but order items, and the second argument is the order ID for which we want to compute the order revenue, and you can see the revenue here. So this is how you can actually use the reduce approach also. So we'll actually talk about these MapReduce APIs quite a bit when we actually get into Spark core APIs, and hence even if you could not get everything at this time, that is fine. But make sure you practice as much as you can so that you understand the underlying functionality of these very, very important functions as we get into Spark very soon.